This is the, I'm going to work questions 2, 10, and 16 on the homework, just in case you need it. When I write equations, I do have to be aware of diatomic molecules, but some elements can just have the chemical symbol written, like a metal. Metals can just have the chemical symbol. Zinc can have the chemical symbol. Now, I don't care about the oxidation number of zinc on this side because it's by itself, but I will have to have it on the other side. It's going to react with copper 3 sulfate. Copper is a +3. Sulfate is a -2. To zero out the oxidation numbers, I will need 2 coppers and 3 sulfates to make those 0. Now, I do not transfer subscripts when I write my products, but I do have to worry about and cancel out oxidation numbers. So I get a product of zinc sulfate. Zinc always has a +2 charge because it's part of the diagonal rule, and then sulfate has a -2 charge, so those oxidation numbers cancel out, and then I get a solid copper product produced. And again, it's metal, so copper can be by itself. I have all the formulas written correctly. Now it is a balancing act. I'm going to start with my polyatomic sulfate. On the product side, I have 3 sulfates, but I only have 1 on the reactant side, so I need to have 3 moles of zinc sulfate. Now you can balance either one, zinc, or you can balance copper. It just doesn't matter. I'm going to balance copper. I have 2 coppers on the reactant side. I only have 1 on the product side, so I need to have 2 moles of copper on my products. And same thing, I have 3 zincs on my product. Now I need 3 zincs on my reactant and just 1 mole of copper sulfate. So that's what number 2 would look like. Number 10. Number 2 is a single replacement reaction, FYI. Number 10, writing the formulas. I have iron 3 chloride. Iron's a +3. Chlorine is a halogen, and that's a -1. So I need 3 chlorines to cancel out those oxidation numbers. Ammonium is NH4. It has a positive charge. Hydroxide is OH-, just 1 of each. Now these are polyatomics, and I do not need parentheses because only 1 of each is needed to make those 0 on the oxidation numbers. So I have my 2 products created. I'm going to have iron hydroxide. Subscripts do not transfer, but oxidation numbers remain the same. Iron in this reaction has a +3 on the reactant side, and it still has a +3 on the product. So I have Fe +3, and then hydroxide OH-. I need 3 hydroxides to cancel out that iron in the +3 state. Now I need to write the formula for ammonium chloride. NH4 still remains positive. Chlorine is still going to be negative, and 1 of each is needed there. Now I need to balance it. So again, I have a polyatomic of hydroxide. I have 3 hydroxides on my product, which means I need 3 hydroxides on my reactant. So I fix my hydroxide. Now I need to fix my ammonium on the product side because I only have 1 and I need 3. So I put a 3 there. Changes my chlorine to 3, which is what I need. So I have balanced this equation correctly now. Question 16, and the back side of this is more like what you will see on assessments, is the full sentence, and it doesn't give you the pluses and the yields, so you have to read and get those context clues as far as the structure and the words and what things mean. So aluminum sulfate is my salt, so aluminum is a +3 and is part of the diagonal rule. Sulfate is -2, so I need 2 aluminums and I need 3 sulfates. Reacts with means plus. Calcium hydroxide, calcium is a +2, hydroxide is a -, so I will need 2 hydroxides. To form is the yield arrow. We produce aluminum hydroxide. Again, subscripts do not transfer, but oxidation numbers remain the same. So aluminum is still a +3, hydroxide is still a -, and I need 3 hydroxides. And the last product I create is calcium sulfate. Calcium is a +2, sulfate is a -2. Those cancel out. So that is the correct formula. Now we're going to balance. I have a choice. I've got sulfate, polyatomic, or hydroxide. Polyatomic, I'm going to choose the hydroxide. The reason being is I have 2 on my reactant side, and I have 3 on the product side, and the only way to get that is to least common multiple of 6. So I need 3 moles of calcium hydroxide on the reactant, and I need 2 moles of aluminum hydroxide on the product. So I fixed my hydroxides. So now I need to check my calciums and my sulfates. Actually, I'm going to check my sulfate because that's my polyatomic I'm going to look at next. I have 3 sulfates on the product, but I only have 1 on the reactant, so I need 3 moles of calcium sulfate on the product. And so that fixes it because I need to have 3 calciums on the reactant. Now I have 3 calciums on the product. I have 2 aluminums on the reactant. Now I have 2 on the product. So this is the balanced equation for number 16. And put 1 mole in front of aluminum sulfate.